Day 477 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3197. Find the minimum area to cover all ones 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D binary array grid. You need to find 3 non-overlapping rectangles having non-zero areas with horizontal and vertical sides such that all of the ones in grid lie inside these rectangles. Return the minimum possible sum of the area of these rectangles. Note that the rectangles are allowed to touch. So first thing I want to say is, as y'all can see, this is the second part of this problem. If you want to check out the first part of this problem, check out yesterday's video. That will be find the minimum area to cover all ones 1. I think that's a good prerequisite to try to solve before you get into this problem. It's a medium problem. So that was day 476. So I suggest you go check out day 476 before we get into this problem if you haven't already, so you'll have a better understanding. Now, let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have our input grid equals a 2D binary array grid, and it has two arrays, first array being 101, second array being 111. So as you can see, this represents the top row, boom, and this represents the bottom row, boom. What we want to do is we want to find 3 non-overlapping rectangles having non-zero areas with horizontal and vertical sides such that all the ones in the grid lie inside these rectangles. So as you can see, we have one rectangle here. A square counts as a rectangle. So we have one rectangle here, we have one rectangle here, and we have one rectangle here. And with these 3 rectangles, we were able to fit all of the ones into these 3 rectangles, right? So it says the ones at 0, 0, and 1, 0 are covered by a rectangle of area 2. So, and then the ones at 0, 2, and 1, 2 are covered by a rectangle with an area of 2. And then the one at 1, 1 is covered by a rectangle with an area of 1. So all of these are highlighted for us. And as you can see, there's the area we're going by basically, in this case, is just this is 1, this is 2, this is 3, this is 4, this is 5. That's how the area is 5. So just in case that didn't make sense, y'all, let's take a look at example 2. So in example 2, we have our input grid equals a 2D array of integers. First array being 1, 0, 1, 0. Second array being 0, 1, 0, 1. This time the output is 5. Explanation says the ones at 0, 0 and 0, 2 are covered by a rectangle of area 3. So that's this rectangle right here. Boom. This has an area of 3. 1, 2, 3. Boom. Then the one at 1 and 1 is covered by a rectangle by an area of 1. So that's this one right here, and as you can see, it's only 1. Boom. So now we have 1, 2, 3, 4. Then the one at 1, 3 is covered by a rectangle of area 1. So that's this rectangle right here. So we add that to the 4 we already have, and in total we have 5. We need to make sure we include, or we have 3 rectangles in total, and we do. So that's why the output is 5. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Now, as I'm sure you have imagined, this solution is a little lengthy, so make sure y'all are paying attention to what's going on because it's a lot to take in. Now, the first thing we're going to do is we're going to create a helper function that's going to find the minimum bounding rectangle that covers all ones in the given subgrid. So we're going to come outside of this main function, come outside of it, we're going to create a helper function. We're going to, helper function is going to be called func min sum 2. Open up the parentheses, we're going to say underscore grid colon to the array of integers. Boom. Come outside of those square brackets. We are going to say underscore u colon, that's going to be an integer. Come outside of that, comma, underscore d colon, that's going to be an integer, comma, underscore l colon, that's going to be an integer, comma, and underscore r colon, that's going to be an integer as well, and it's going to return, you guessed it, an integer. Boom. So then we're going to open up the brackets. Now the smallest row index containing a 1, we're going to create the variable for that by saying var min underscore I. We're going to set that equal to grid.count. Boom. Then we're going to get the largest row index containing a 1 by saying var max underscore I. And we're going to set that equal, we're going to set that equal to 0. Boom. Then we're going to get the smallest column index containing a 1. Come underneath that, we're going to say var min underscore j. We're going to set that equal to grid dot first question mark, because it's optional, dot count. Then we're going to say question mark 0. Boom. Then we need to get the largest column index containing a 1. So we're going to declare a variable called max underscore j, and we're going to set that equal to 0. Then we're going to iterate through the specified subgrid by saying for I n u dot 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 d. We're going to open up the brackets. Then we're going to say for j and l dot dot, sorry, that should be l dot 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 r. We're going to open up the brackets. Boom. Then we're going to say if grid square bracket I square bracket j equals 1, then we're going to open up the bracket and we're going to update the bounding box coordinate by saying min underscore I. We're going to now set that equal to min, open up the parentheses, min underscore I, comma I, come underneath that, and we are going to say min underscore j equals min, open up the parentheses, min underscore j, comma j, come underneath that, we're going to say max underscore I. We're going to set that equal to max, open up the parentheses, max underscore I, comma I. And then we're going to say max underscore j, set that equal to max, open up the parentheses, max underscore j, comma j. Boom. And if at least one was found, we're going to return the area of the bounding rectangle. Otherwise, we're going to return a very large number, so it won't be chosen as the minimum. So we could just come right here and we could say return min underscore I is greater than or equal to max underscore I. Then we're going to open up the brackets. Or sorry, y'all, we're not going to open up the brackets just yet. We're going to say question mark. This is going to return a Boolean for us. So if it's true, we're going to say question mark, open up the parentheses, we're going to say max underscore I minus min underscore I plus 1 times, come outside the parentheses, and we're going to say times, open up more parentheses, max underscore j minus min underscore j plus 1. Then we're just going to come outside these parentheses and we'll say colon int dot max divided by 3. Boom. Then we're not done yet. We have another helper function. We actually have 2 more helper functions, so make sure y'all are paying attention. This helper function is going to rotate the grid 90 degrees clockwise for us. So we're going to say func rotate, open up the parentheses, underscore, grid, colon. That's going to be a 2D array of integers. Boom. And this will come outside of that, and it's going to return a 2D array of integers. Boom. Then we're going to open up the brackets, and we are going to get the number of rows by saying let n equal grid.count. Come underneath that. We're going to say let m equal grid.first question mark dot count question mark 0, and that's going to get the number of columns. Then we're going to create a new grid with a transposed dimensions by declaring a variable. We call it ret. Set that equal to a 2D array of integers. Come outside of that, open up the parentheses. It's going to be repeating colon an array of integers. Come outside of that, open up the parentheses. That's going to be repeating colon 0 comma count colon n. Come outside of those parentheses, still inside the other parentheses, and we're going to say count colon m. Then we're going to come underneath this. We're going to say for I in 0 dot dot less than sign n, open up the brackets, and we're going to say for j in 0 dot dot less than sign m, open up the brackets. We're going to say ret square bracket m minus j minus 1. Come outside of that, open up more square brackets I. Then we're going to set that equal to grid square bracket I square bracket j. Then we could just come right here and we can say return ret. Boom. Now we're going to create another function that's going to try different ways of splitting the grid into 3 rectangles and compute the minimum possible sum of bounding boxes of ones. So for that, come outside of this function, another helper function, we'll call this func solve. We'll open up the parentheses, underscore grid, colon. That's going to be a 2D array of integers. And the whole function is going to return an integer. Then we'll open up the brackets. We'll say, once again, we'll say let n equal grid.count, and we'll say let m equal grid.first question mark dot count question mark is 0. Boom. Then we need to initialize a large value again, so we're going to just say, come underneath this, declare a variable called res equals n times n. Come underneath this. Then we're going to, for case 1, we're going to split into top plus bottom minus left plus bottom minus right, and top minus left plus top minus right plus bottom. So we're going to say for I in 0 dot dot less than n minus 1, we're going to open up the brackets. Then we're going to say for j in 0 dot dot less than m minus 1, open up the brackets, and we're going to say let a equal min sum 2, which is the helper function we created. We're going to open up the parentheses. We're going to say grid, comma 0, comma I, comma 0, comma m minus 1. Come outside of this. Outside of parentheses, we're going to say plus. Then we're going to come underneath that, and we are going to say min sum 2 again. This time, open up the parentheses. We're going to pass in grid, comma I, plus 1, comma n minus 1, comma 0, comma j. Once again, come outside of that. We're going to say plus min sum 2, open up the parentheses, grid, comma I plus 1, comma n minus 1, comma j plus 1, comma, m minus 1. Boom. Now for the vertical split, left and right, come underneath this, and we are going to say let B equal, then we're going to say min sum 2, open up the parentheses, grid, comma 0, comma I, comma 0, comma J. Then we're going to say plus min sum 2, open up the parentheses, we're going to say grid, comma 0, comma I, comma J, plus J plus 1, comma M minus 1. Then we're going to say plus again, come underneath it, min sum 2, open up the parentheses, and it's a grid, comma I plus 1, comma N minus 1, comma 0, comma M minus 1. Boom. Then we're going to update the result with the smaller option by coming up down here underneath this, and we're going to say return min, open up the parentheses, res, comma A, comma B. Boom. But we're not done yet because we're coming underneath this for loop. When for case 2, we're going to split the grid into 3 horizontal stripes. So we can say for I in 0, dot dot less than n minus 2, open up the brackets, for j in I plus 1, dot dot less than n minus 1. We're going to open up the brackets, and we're going to say let C equal min sum 2, open up the parentheses, grid, comma 0, comma I, comma 0, comma M minus 1. Come outside of that, we're going to say plus, then we'll say min sum 2, open up the parentheses, grid, comma I, plus 1, comma J, comma 0, comma M minus 1. Boom. Come outside of that, we're going to say plus. We'll say min sum 2 again. Open up the parentheses, grid, comma J plus 1, comma N minus 1, comma 0, comma M minus 1. Come underneath that, and we are going to say res equals min, open up the parentheses, res, comma C. Then we come right here, and we could just say return res. Now we're making some progress, y'all, but we're not done yet because we still need to go up here and fix this main function, right? So we need to rotate the grid 90 degrees to check both orientations. So we're just gonna say let R grid equal rotate, open up the parentheses, grid, come underneath that, and we're going to return the minimum result between solving on the original grid and solving on the sorry y'all, got a code, but we're going to return the minimum result between solving on the original grid and solving on the rotated grid by saying return min, open up the parentheses, solve, open up the parentheses, grid, come outside of the first parentheses, say comma, solve, open up the parentheses, pass in R grid. Now that should be all she wrote, y'all. So let's run it before we submit it. Make sure it works properly. Ooh, first try, that's what I'm talking about. So let's go ahead and submit it. Make sure it still works after we submit it. Ooh, we got the wrong answer. Okay, so what that means is So it's accepted, but then we got the wrong answer. So somewhere the math is not mathing. So give me a moment while I check all this math to make sure. Gotta make sure the maths correctly. Oh, y'all, my bad. It's this right here. This shouldn't be return. This should be res equals. So now let's submit it and see if that works. Sorry about that, y'all. And it's accepted, y'all. Look at that. So with that being said, let's make sure you get one more look at the code. It's the top part. This the uh, this is the first helper function. Boom. Then this is the second helper function. Boom. Then this is the third helper function. This is the top part of the third helper function. This is the bottom part of the third helper function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.